All right, so here we are, the last reading of the Rocks and Minerals unit, and it is on the rock cycle. Okay, so what is the rock cycle? Only one key question answered in this reading. So let's scroll down to the page here. What is the rock cycle? Natural forces on the Himalayas act on the Himalayas. In fact, rock in the Earth's crust is always changing. Forces deep inside the earth and at the surface produce a slow cycle that builds, destroys, and changes the rocks in the crust. So that is what the rock cycle is. Key question being answered. The definition here, the rock cycle is a series of processes that occur on Earth's surface and in the crust and mantle that slowly change rocks from one kind to another. For example, weathering can break down granite into sediment that later forms sandstone. One pathway through the rock cycle. There are many pathways by which rocks move through the rock cycle. For example, Stone Mountain near Atlanta, Georgia, is made of granite. The granite in Stone Mountain, shown in Figure 1, formed millions of years ago below Earth's surface as magma cooled. After granite had formed, the forces of mountain building slowly pushed the granite upward. Then, over millions of years, weathering and erosion began to wear away the granite. Today, particles of granite constantly break off the mountain and become sand. Streams carry the sand to the ocean. What might happen next? Over millions of years, layers of sand might pile up on the ocean floor. Slowly, the sand would be compacted by its own weight. Or perhaps calcite that is dissolved in the ocean water would cement the particles together. Over time, the quartz that once formed the granite of Stone Mountain could become sandstone, which is sedimentary rock. Sediment could keep piling up on sandstone. Eventually, pressure would compact the rock's particles until no spaces were left behind them. Silica, the main ingredient in quartz, would replace the calcite cement. The rock's texture would change from gritty to smooth. Over millions of years, the sandstone would have changed into the metamorphic rock quartzite. So there's Figure 1. There's Stone Mountain. Again, the granite in Stone Mountain is moving through the rock cycle. Rock cycle. How do rocks form? Through melting, weathering, and erosion, and heat and pressure, the rock cycle constantly changes rock from one type into another. So here is, maybe I'm going to zoom out here. We'll see how this goes. Here is the rock cycle in a nutshell. And you can see here that you have igneous, you have sedimentary rock, and you have metamorphic rock. Okay, so through melting, metamorphic rock can turn into magma, and through cooling and solidification of that magma, it can become igneous rock. Weathering and erosion can turn into sediment. The sediment is deposited, and that becomes sedimentary rock. Okay, so you would have to fill in this diagram all the way to fully understand. So through melting, turns into magma. So sedimentary rock can melt, turn into magma, and become cool and solidify and become igneous rock. Okay. The rock cycle and plate tectonics. The changes of the rock cycle are closely related to plate tectonics. Recall the Earth's lithosphere is made up of huge plates. These plates move slowly over Earth's surface as a result of convection currents in Earth's mantle. As plates move, they carry continents and ocean floors with them. Plate movements help drive the rock cycle by helping to form magma, the source of igneous rock. Where ocean plates move apart, magma formed from melted mantle, rock moves upward and fills the gaps with new igneous rock. Where the ocean plate is subducted beneath a continental plate, magma forms and rises. The result is a volcano made of igneous rock. A collision of continental plates may push rocks so deep that they melt to form magma, melting the formation of igneous rock, or leading to the formation of igneous rock. Sedimentary rock can also result from plate movement. For example, the collision of continental plates can be strong enough to push up a mountain range. Then weathering and erosion begin. The mountain can be worn away. The process leads to the formation of sedimentary rock. Finally, a collision between continental plates can push rock down deep beneath the surface. Here, heat and pressure would change the rock to metamorphic rock. And then you have the conservation of material in the rock cycle. Constructive and destructive forces build and destroy Earth's land masses, but as the rocks and Earth's crust moves through the rock cycle, material is not lost or gained. For example, a mountain can erode to form sediment, all of which can eventually form new rock. So there you go, boys and girls. That is the rock cycle. Thanks for listening. Have a wonderful rest of your day.